Hey guys, welcome to another Algebra 2B video. This time we're talking lesson 12.4, geometric sequences and series. And when I think of these, of course, I think of Serena Williams, don't you? She was the winner out of 128 players in the 2003 Wimbledon Ladies Single Championship. After each match, the winner continues to the next round and the loser is eliminated from the tournament. This means that after every round, only half the players are left. The number of players remaining after each round can be modeled by what we call a geometric sequence. In a geometric sequence, the ratio of successive terms is constant and is called a common ratio R. And R cannot be 1 because then you wouldn't have any change. So for a tournament like Wimbledon or even a tournament like March Madness, which I hope they have this year, R is 1/2. So if you remember, in an arithmetic sequence, we were looking at a common difference, and we were adding or subtracting every single time. Now we're multiplying. So if we look here, they start out with 128 players, and then after one round, there's 64. So half of them are gone, and then it's 32, and then it's 16, and so on. So we get a common ratio of 1/2 every time. It's kind of like an exponential decay kind of situation, if you remember that from earlier in 2B, lesson, I think it was chapter 7. Anyway, exponential functions always have a common ratio, so when you graph them, you see this kind of a curve. How do I identify a geometric sequence? So, well, if you look at your note sheet, like I just kind of said, to determine whether a sequence is geometric, check for a common ratio. So unlike 12.3, where we were finding a difference and subtracting every time, we're dividing. 6 divided by -2 is -3. -18 divided by 6, -3. 54 divided by -18, -3. 162 divided by 54, -3. So the common ratio is -3. Now, like arithmetic sequences, there's a formula that we use to find any term in a geometric sequence, and it's this guy here. A sub n equals AR, or I'm sorry, not AR, A1 times R to the n minus 1. Got a little ahead of myself there. So if we look at what we have here, we have this sequence here, and again, we're looking for that 10th term. So we're going to say n is 10. I know that's 10. I've got to find R first. So, and again, the big hint here is that they said it was geometric, so I don't have to do all of this stuff. But I'm going to say, all right, 12 divided by 3 is 4. So R equals 4. A1, that's easy. It's right there. So if we put them all together, we would get 3 times R. Let's do it the right way. So we would have A sub n equals A1 times R to the n minus 1. So A sub 10 is 3 times R is 4 to the 10 minus 1. And I kind of worked it out here. 3 times 4 to the 9th. You get, wow, 786,432. Yeah, geometric sequences get big really quick, depending upon what that R value is. All right, so let's take a look at some sample problems. How do I know if I have a geometric sequence? I have to see if I have a common ratio. So let's see, 12 divided by -6 is -2. -24 divided by 12 is, guess what, -2. -48 divided by not -48, oops, got ahead of myself again. 48 divided by -12, -20, 48 divided by -24 is -2. All right, I'm going to call it. I'm going to say yes, R is -2. Let's look at number 2. This one should look familiar to you from the previous lesson. 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27, guess what that is? It's 3. So again, I'm going to say yes to number 2. R equals 3. Number 3, let's see, 60 divided by 10 is 6. 110 divided by 60 is 1.83 repeating. So, no. I don't even have to do any more than that. Once I've gotten one ratio that's different, I'm done. That's not. All right. So, let's see if we can't figure this stuff out. This time we were looking for the 8th term. And we're going to use, again, a sub n equals a1 times r to the n minus 1. So step 1 is to find r. Something a pirate says. No, it is the common ratio. 14 divided by negative 7 is negative 2. All right, so r is negative 2. A1 is that first term. It's negative 7. And n is 8. So I'm going to say a sub 8 is going to be negative 7 times negative 2 to the 8 minus 1 power. A sub 8 is negative 7 times negative 2 to the 7th power. Negative 7. If you're friendly with parentheses, you could evaluate this on your calculator, and it is 896. Number 5. 24 divided by 8 is 3, right? Yeah, 3. A1 is 8. N is 8. So a sub 8 is going to be 8 times 3 to the 8 minus 1. So a sub 8 will be 8 times 3 to the 7th, which is going to be another very large number. In fact, it is 17,496. So these numbers get big pretty darn quick. All right, back to the textbook. Example 1 talks about finding that common ratio, and then they kind of show you this common ratio formula. And basically what we get is, like we said, a sub n is a1 times r to the n minus 1. Example 2 kind of goes over what we just went over in the notes. And then we get finding the nth term. So let's go back to the note packet to page 2. Because remember, we did this with arithmetic sequences too. So to find any two terms of a geometric sequence, you first find the common ratio, then you use the formula for the nth term to find the first term, and then you find the nth term. So if you know two terms, you can find any other term. And again, like we talked about before, it is this 3-step process. Step 1 is to find the ratio, step 2 is to find a1, and then step 3 is to find that term. So 1, find r, 2, find a1, and then 3 will be to find a sub n. So let's look at the example and then we'll do one together. Find the 8th term where a4 is 162 and a6 is 1458. These numbers are going to be big, but don't worry about it. So we get a sub n equals a1 times r to the n minus 1. Plug in them and we get solve for r, we would have to divide by 162 and then take the square root because we have r squared, so we get plus or minus 3. So here's where it gets a little different. R could be 3 or it could be negative 3. So I have to figure out what A1 would be if R is 3. If it's positive, we get an A1 of 6. If it's negative 3, we get an A1 of negative 6. So we actually have to do that step 2 twice because R could be positive, it could be negative. We can't tell based on the information. So then we're going to plug in 3 and 6 and find that 8th term. And when you work it out, you get 13,122. And then we'll try it with negative 3 and negative 6. And we work it out. Oh, we get 13,122. So it doesn't really matter. In both cases, we're still going to get 13,122. So you kind of have to check, especially if there's a possibility that you have a negative ratio. All right, so let's try it together. Let's see. So they are looking for the 7th term. A4 is 80, A5 is 160. So we're going to do this. AN is A1 times R to the n minus 1. All right, so first of all, let's find R. So we'll plug in what we know. A to the 5th is A to the 4th, R to the 5 minus 4. So this is good. We get 160 equals 80 times R to the 1st. So basically just divide by 180. Or I'm sorry, divide by 80. And we get R is 2. Right? Because 160 divided by 80 is 2. Yeah, sorry. So then we're going to find A1. So I'm going to use A4 and say A1 is that 2 times 4 minus 1. So A4 is, well, I know A4. A4 is 80 equals A1 times 2 to the 3rd power. 80 is A1 times 8. Divide by 8. And A1 is 10. And then, so we want to find the 7th term, so we're going to say A sub 7 is 10 times 2 to the 7 minus 1. So A sub 7 is equal to 10 times 2 to the 6th. And that is 2 to the 6th power is 64 times 10 is 640. All right, so if we flip back to the text, we're going to talk about a geometric, two things. First of all, geometric means. Geometric means are terms between any two non-consecutive terms in a geometric sequence. So if A and B are both terms in a sequence with exactly one term between them, the geometric mean is given by the square root of A times B. So if you're given two terms and they say find the geometric mean between, say, 1/2 and 1/32, it's just going to be the square root of 1/2 times 1/32 of the square root of 1/64, 1/8. So if I wanted to find, say, the geometric mean between 16 and 25, we go back here where I can write stuff down. So geometric mean between 16 and 25, it's just going to be the square root of 16 times 25, which is 400. Square root of 400 is 20. So the geometric mean between 16 and 25 is 20. It's just the square root of AB. All right, the next thing is a series. And remember, we found the sum of terms in an arithmetic sequence. There's also a formula that you can use to find the sum of the terms in a geometric sequence. And they go through all this math stuff, but they end up getting this. S sub n equals A1 times 1 minus r to the n divided by 1 minus r. So basically, if you know r, and you know n, and you know the first term, you can find the sum of any number of terms in a geometric series. So how does that work? So if we look at this example number 5 here, we got find the sum of the first 7 terms for 3 minus 6 plus 12, negative 24, and so on. So first of all, you find the ratio. Negative 6 divided by 3 is negative 2. First term is 3, n is 7. Plug them all in. 3 times 1 minus negative 2 to the 7th divided by 1 minus negative 2. So that would be 1 minus negative 128 divided by 3 times 3. So the 3's kind of cancel out. So you just get 129. And you could use a graph calculator to figure that out if you really wanted to, and I will probably show you guys how to in class. Here we have the sum from 1 to 5. It's summation notation of 1/3 to the k minus 1. So find that first term. 1/3 to the 1 minus 1, that's 1, because anything to the 0 power is 1. So then we find the fifth term. Actually, we don't even need to find the fifth term. We're just going to plug in. All we need is A1. So 1 times 1 minus 1/3 to the 5th divided by 1 minus 1/3. 1 minus 1 243rd divided by 2/3. That's just going to be some fractions. Multiply them out. You get about 1.49. 121 divided by 81. So there it is. We want to do this for our own. Sum from 6, so S sub 6, and we got 2, 1, 1/2, 1/4. So basically, R is going to be 1/2. A1 is 2. So the sum here is going to be 2 times 1 minus 1/2 to the 6th divided by 1 minus 1/2. It's always going to be Sn equals A1 times 1 minus R to the n over 1 minus R. So it can get a little complicated, not going to lie. 1/2 to the 6th is 1/64th. So we're going to get 2 times 1 minus 1/64th divided by 1/2. 1 minus 1/64th is 63/64ths times 2, and divided by 1/2 is like times 2 again. So I'm going to do this. 4 times 63/64ths. And you could type that into your calculator just by saying, because 2 times 2 is 4. If you type it in the calculator like this, you don't even need to use any fraction stuff. I get 3.9375, which is actually 63/16. Yeah. Not the nicest answer, but it is an answer. If you look at the next example, we got the sum from 1 to 6. Negative 3 times 2 to the k minus 1. Right? Yeah. So Now for this one, just got to find A1. And that is going to be -3 times 2 to the 0. That is -3. N is 6. R is 2. So we get sum from 1 to 6 of -3. 1 minus 2 to the 6th divided by 1 minus 2, which is -3 times 1 minus 64 over -3, which is -63, because the -3's cancel out. And I will go back and show you this example here. How do we know R was 1/3? Because that's what was being raised to the power. So that's it. There is the sports application, which I'm sure everyone loves the sports, right? So the Wimbledon Single Ladies Championship began with 128 players, and they compete until there's only one winner. Apparently the Williams sisters played each other. How many matches must be scheduled in order to complete the entire tournament? All right, so we got to figure out the number of rounds. We are really not sure the number of rounds, but we need to find the sum. So A sub n is going to be 64 times 1/2 to the n minus 1. So if we figure out how many are going to be in the first round, we substitute in 1. Final round is going to have 1 match. We don't know what that n is, but 64 times 1/2 to the n minus 1 equals 1. So we get 1/64 equals 1/2 to the n minus 1. 1/64 is 1/2 to the 6th, so n minus 1 is 6, so n is 7. So we're going to need 7 rounds. And if we plug it all in, it's going to be 127 matches. So if there's 128 players, you need 127 matches. So that's it. A lot going on in this one, I'm not going to lie. We're going to spend a couple days on this, and hopefully you will ask me questions if you have them. I hope you learned something today. If you did, smash that like button, and I will see you in the next one.